All right, that's the top of the hour. Welcome to the Institute for Catastrophic Loss Reduction's forecast webinar for this wildfire season. It's Tuesday, May 7th, 2024, and I'm your host, ICLR Chief Engineer, Dr. Keith Porter. This is one in an annual wildfire forecast webinar series hosted by ICLR, Canada's leading source for disaster resilience knowledge. As in ICLR fire forecast webinars since 2018, today's speaker is Richard Carr from Natural Resources Canada. Richard is one of Canada's most respected fire weather experts. He's a geographer by education with about 30 years experience in meteorological modeling, especially for near real-time historical wildfire meteorology. Fire agencies across Canada turn to him for fire risk forecasts. That includes his own Canadian Forest Services Fire Group within Natural Resources Canada, the Canadian Interagency Forest Fire Centre, and federal emergency response agencies. To learn more about Richard's work, Google Canadian Wildland Fire Information System. Before our speaker begins, here's our agenda. Our webinar will last 90 minutes. Our speaker will present for about half that time, then I will moderate Q&A for the rest of the time. Please feel free to chat your questions into the Q&A box. I will try to pose your questions in the order they appear in the Q&A box. So if we have a lot of questions, I may only pose your first question, then move on to others, then circle back to your additional questions. Our webinar is recorded. ICLR will post our speakers' slides and a link to the video in the next day or so. So if you have colleagues who couldn't attend, please let them know. And with that, I will turn it over to Richard.
All right, thank you very much, Keith, for the introduction, and glad to present to your group again. So welcome to the 2024 seasonal forecast. Something I like to do is to draw on some of the slides. You just use the PowerPoint drawing tool. So I'll probably draw some shapes using a purple highlighter, and looks like I've got to reactivate it. Let me just try again. There we go. So I'll draw on slides occasionally like that, might point out certain features or points of information on there. So my mouse does get out of control sometimes, so I apologize if we get some jaggies on the drawing. I might have to erase it and try it again. So hopefully the mouse will behave today. All right, so with that introduction, we'll just dive into the material here. I'll probably pause a little bit with each slide advance just to make sure the audio syncs up with the slide. We'll start out by looking at 2023 in review, since it was such an unusual year, and it's probably going to be talked about for a long time and studied for quite a long time as well. So we will just take a look at what happened during 2023 and then get into the 2024 details and forecast. So I'm going to start this off with a bit of media information here. So all the numbers below were compiled from the May to September period by our media response team within Natural Resources Canada. We've got some media people and science communications people that are involved in that. A quote at the top of that came from some interview I did fairly early in the season, but we already had a large number of fires, and a lot of them were large, so we had a lot of area burned at the time. But they kind of wanted to know how much area burned and how many fires there were, but I really didn't want to throw out some numbers just because they were changing so quickly that by the next day they were just completely obliterated with new figures. So that's the type of year it was. It was just really hard to keep up with the pace of fires, and especially area burned. The actual number of fires wasn't that unusual. It was a little bit above normal, but the area burned, of course, was really huge. So during the season, just with the numbers coming in through the Canadian Interagency Forest Fire Centre, we kind of came up with about an 18 million hectares burned. If you're from the US and use acres, well, multiply that by about 2.5 and you can get the number of acres. But with some revised mapping, that area burned was actually brought down to probably about somewhere between 15 and 16 million hectares burned, but really still about double the previous record that we had set in 1989. So with the media response, there's a bunch of numbers at the bottom here. So we handled over 450 individual media requests. And in our CAN, researchers were quoted in over 5,500 articles. So a lot of these were picked up by other news outlets. So once one interview is done, it might have been picked up by several others. But these type of articles were spread around the world pretty quickly. The number in blue there, the daily record high of media articles published at over 545. Not just in one day. That was kind of equivalent to what we'd set in entire seasons not too long ago. So a huge amount of media interest in 2023 fire season. Daily average about 40 articles per day. These were broadcast or printed in about 34 different countries and a number of languages, about 22. Of course, we didn't do interviews ourselves in more than English and French, as far as I'm aware, but we do have translation services, or some of the media outlets may have translation services as well. So it did get translated to quite a number of languages. If we look at the fire season summary, just hotspots these are thermal signatures from satellite instruments. The black line is the 2023 figure, so we can get a somewhat reasonable estimate of the area burned based on these hotspots, knowing the size of the pixel and counting the number of hotspots. So we can see some big spikes in here. The tallest one is in June, and then we had another really big one late in September. So I think there's a few notable things to bring out of this chart here. This features the last 6 or 7 years of data, plus a mean value for the past 20 years. The mean value is kind of a broad gray line just in the background. You can see it fairly low through the plot here. So we've had a lot of active fire years out of those past few years, but what's really notable is the number of hotspots we picked up early in the season. Some of the fires, Alberta started late in April and accelerated in May. I'll take a look at that on another slide here shortly. And lots of area burned in June, when usually we have fairly adequate rainfall across the country to kind of quiet things down a bit. And the big spike later in the month, and then a lot of activity late in the year here. And if you look at the colored lines underneath there, they just barely show up. So fairly unusual to have that huge amount of area burned in what we call the shoulder season, both early in the spring and late in the summer or early in the autumn. So that's one thing that really distinguished 2023 from a lot of other fire years. As we're going to walk through the summary here, just the red circles highlight some increases in area burned. So once again, the black line here is the area burned accumulated as the season went on. And these are kind of numbers from satellite hotspots as well. So once again, we come out near that 18 million hectare mark at the very end, but with enhanced mapping, it tends to eliminate some areas within fires that maybe didn't burn, things like maybe wet areas or certain fuel types that might have been included in the perimeter, but really didn't suffer much fire damage. So the total was probably reduced somewhat from that, but still very high. So once again, we've got probably about 10 years or so of previous years in the colored line, so we can just see how much above all of these other years that 2023 stood up. So Yeah, west central Alberta, northeastern BC, central Saskatchewan. Some fires in Northwest Territories and Nova Scotia all happened in that May period, pretty much. It was fairly dry. West central Alberta did start to get some good rainfall beginning in about the third week of May. So, where the big fire started, got shut down again by the end of the month, just because of that rainfall. But areas outside that area kept burning and fire activity kept increasing. By the time we got into June, we saw fires in Ontario and Quebec start to flare up, and of course, Quebec set a record area burn. They had some really huge fires there, and the area east of James Bay is prone to fire, but the biggest fire occurred in that area, and there was also some large fire activity a little bit further south in their managed forest zone. So some of those were probably the largest fires recorded in that managed forest area as well. So a huge amount of fire activity in Quebec through June. By the end of the month, about June 27th, we broke that previous national record area burned. The date may not be perfect just because the revised mapping might suggest that we broke that record maybe on a slightly different date. July, we started to get activity up north, so in Northwest Territories and Yukon. Saw a lot of area burned through that period. A lot of the fire activity in Quebec kept going for a part of July at least, and then later in the month, we started to see some better rainfall through that region. So it gradually reduced fire activity through the eastern part of the country. August and September saw a few periods of fairly rapid fire growth through British Columbia, northwestern Alberta, and Northwest Territories. And a lot of these were wind driven. And what was really unusual was the wind event near the end of September, that uppermost upper right red circle there with a huge amount of area burned on September 22nd. And a lot of that was up along the 60th parallel in British Columbia, Alberta, and Northwest Territories. A few other records set in 2023. Well, we had record provincial area burned in British Columbia, Northwest Territories, Alberta, Quebec, and Nova Scotia. Largest fires on record in British Columbia, Nova Scotia, and Quebec. The Canadian Interagency Forest Fire Center National Preparedness Level, or NPL, was at 5 from May 11th to September 7th. That was earliest onset of NPL 5 and the longest continuous period on record at 120 days. So that colored scale just underneath there gives the indication of the scale. The 1 is blue, the quietest. There's not much fire activity happening, and 5, we're seeing incredible activity, and suppression resources are pretty much tapped out through Canada and possibly in the US as well. When we get to level 3, that orange color there, we're starting to look forward to see if we're going to need cruiser equipment from other nations. So there's a few activities that kick in gear to prepare for that. 2023, we had international crews from 11 nations at various times over the season. So once again, that was a record number. And agreements with some of those nations were kind of hashed out as the season went on. And they're usually temporary in nature, but again, it is starting to negotiate some permanent agreements with some of these countries. Environment and Climate Change Canada, or ECCC, had a record number of smoke alerts issued during 2023. So they do issue air quality or smog alerts and things like that. So a record number of those. Evacuations, about 270 evacuation locations, and evacuees totaled somewhere around 230,000. And those numbers are not exact, but once again, records set in 2023. Some of the leading factors, looking at some of the ocean atmosphere indexes here, we had a fairly quick transition from El Nino after an extended La Nina period. I'll talk about that a little bit later as well. What I call a warm negative Pacific decadal oscillation, or PDO. And if you look at the left-hand blue circle there, it encompasses some of the sea surface temperatures in the north central Pacific and along the west coast of North America. So with these, the blue colors indicate below normal temperatures, white is pretty much normal, and orange or red is above normal. So, if you just looked at the sea surface temperatures along the Pacific coast, well, you might see a lot of warm, and you thought, oh, we're in a positive PDO phase, but you have to look at that north central Pacific as well, which was extremely warm in 2023, especially through the latter part of the summer. So it actually produced a negative PDO in spite of the warmth along the west coast. And, we really don't know the result of kind of a really warm negative PDO. On the other side of the coast, I mean, we had warm Atlantic temperatures as well, but what really look at in the Atlantic is the strength of low pressure systems around Iceland, so that's just outside that circle, and the Azores Islands further south, just off the coast of, I think it's off the coast of Spain. Maybe I'm a little too far south with that. But still an extreme amount of warmth in the oceans, and might have helped drive warmth across a lot of the globe in 2023. Down below that in the tropics, of course, we've got the Nino regions here. So that red box is where the ocean temperatures are measured for the El Nino or La Nina indexes. So fairly warm ocean temperatures, as is typical for an El Nino. It is a pretty strong one as well. So warm temperatures right from the coast of South America, almost stretching out to Indonesia, pretty close to it. So a good plume of warm sea surface temperatures there. Just on the right here, we've got the Pacific decadal oscillation. So we've got that fairly broad period of the negative phase that we've been seeing over the past few years. All right, snow cover may affect spring activity more than summer, but if you have the snow cover disappearing early in the season, well, you might get an earlier start to the fire season, and if things remain dry, well, it might exacerbate summer activity as well. If you look at the end of April 26th on the map here, that's about in that black circle where some of the large fires in Alberta started, and you can see that some of that region probably still should have a bit of snow cover. Anything south or enclosed in those red lines marks the average 2 centimeter snow depth for that particular date. So we often have some snow cover lingering in that region. A lot of that area is kind of a mixed forest and agriculture. Up to the north of those red circles, we've got some fairly good hills or maybe low mountains, elevations up to about 1,300 meters or somewhere around probably 4,000 feet or so. So that area pretty much had the snow cover vanish pretty early, so it left it fairly susceptible to fire. North of that red line, you can see a little bit of white, so up through the northern parts of the Prairie provinces and southern Northwest Territories, so rapid loss of snow cover in that area as well. Take note of northern Ontario. At that point, it still had pretty good snow cover, colors above that red line. These are depths, anomaly depths in centimeters, so the scale is at the left there. So once you get into that blue region, we're probably looking at somewhere in the 30 to 50 centimeter depth above normal for that particular day. So pretty adequate snow cover in northern Ontario heading into the end of April. Once we got into May, though, May 10th, just a couple of weeks later, well, we see a lot of white, so a lot of that is above the red line, north of the red line, so we had fairly rapid snow loss continuing through the territories up through northern Quebec. That patch in northern Ontario is still showing snow cover south of that red line, so there's still some there, but those anomalies were probably reduced from 30 to 50 centimeters, somewhere down to 5 or 10, so pretty rapid snow melt through that area during the early part of May. And then a week later, that had disappeared, and we're left with an awful lot of white pretty much all across Canada and up into Alaska as well. So very rapid snow loss through that period. Drought progression, we have to start in 2022 with the drought. Through the latter part of the summer in 2022, we saw a drought intensify in patchy areas. This is a map from August 31st here. So fairly dry up through the Northwest Territories and parts of Yukon, and patches a little bit further south scattered through the provinces. A bit more of a substantial drought in the southwest Saskatchewan, not really forest in that area except in the Cypress Hills through the spring and the fall seasons, though grass fires can be a problem in some of those areas. As we step through the winter here, at the end of December 2022, we saw that the drought had become more widespread through Western Canada. A little bit of growth of drought areas in the east, but still fairly patchy there. Some improvement in drought over the winter. So looking at the end of April 2023, so still some dry areas that didn't look too excessive at the time, but we do note where the large fires in Alberta and northeastern BC and even into west central Saskatchewan occurred. We were starting to see some drought intensify in those regions again, or maybe linger through the winter. It didn't really improve that much. And some areas maybe it started to intensify through that area. So good indication that we might get some fire through those regions with any warm and windy weather. And we certainly had that at the end of April and beginning of May in 2023. And then by the time we got to October 31st here, well, we saw widespread intensification over the summer. And the one exception was that little patch of west central Alberta. We see a bit of white there with no drought. And at this point, the end of October, the Edmonton area was starting to see an increase in drought, but it was actually included in that area that got good rainfall throughout most of the summer. August was dry, and then September onwards has been quite dry in a lot of these regions. So did see a pretty fairly severe drought through parts of the agricultural region in southern Alberta and maybe southwestern Saskatchewan. A few patches of that exceptional drought, kind of a once in 50-year event, pop up in those areas and parts of the interior of British Columbia as well. So those are the really dark, almost blackish areas there. Now the red, the extreme drought, still pretty serious. So we saw patches of that form in other parts of Alberta, northern BC, and the Northwest Territories. So let's step into the 2024 season to date. Once again, we'll look at the drought map. So last one we looked at was the end of October last year. This one here on the left-hand side is the end of March 2024. The end of April assessment, which is done by Agriculture and Agri-Food Canada, is just underway at the moment. They probably won't have it published for another few days. So maybe the end of the week or early next week, we'll see the April 30th assessment. What we have seen over the winter and early part of the spring is we've had fairly good precipitation in parts of the southern prairies, especially southwestern Alberta as we get closer to the Rocky Mountains. So some of that agricultural region is probably in better shape. Still, some of the streams I think are pretty dry, so we need continued precipitation in that area. Might have helped to hamper any grass fire activity in that region during the spring as well. But up to the north, we still see extensive patches of that severe drought through central British Columbia, up through northwestern Alberta and northeastern British Columbia and up into the territories, and a little patch of exceptional drought to the northwest or west of Prince George, BC, that kind of darkish area in the lower left red splotch there. So fairly significant drought heading into this year. The east tends to get better precipitation throughout the year. If they do get dry periods like we saw through the late spring and early summer 2023, they can certainly have their problems. But I think the drought can be more prolonged in the western half of the country. Once we get into the April 30th assessment, we'll probably see the shades a little bit lighter, maybe bigger white patches through parts of the east. Maybe some areas in the west continue to improve, especially the southern prairies, but I think northern regions are still experiencing fairly substantial drought. Snow cover from May 6th on the right here looks a little bit closer to normal. We've got some areas in the Northwest Territories, maybe northern Manitoba, a few patches around James Bay where the snow cover had disappeared a bit earlier than usual, but and in Labrador, I guess, as well. Um, Still, not quite as dramatic as we saw in 2023. Back to sea surface temperatures again. So the red oval on the left-hand side on the Pacific there shows that we've still got a patch of fairly warm water out in the central Pacific. Temperatures have cooled along the Pacific coast. In the Nino 3.4 region, those El Nino or La Nina indexes or sea surface temperatures indexes are taken. We don't have that warm plume anymore. It's vanished quite rapidly, and we're starting to see some cold water, these blue splotches appear. First along the west coast of South America, and the one out closer to the central Pacific has really appeared in about the past week or so. So what we're really seeing is a fairly good transition from that El Nino back into neutral conditions. We'll talk about the forecast for an upcoming La Nina shortly. On the North Atlantic side here, well, once again, there's patches of warm water there, but a lot more colder water as we head into 2024. Now, we may note that in 2023, we started out with fairly similar ocean temperatures in these areas, and they warmed up quite rapidly as the year progressed. I think, what we might see, though, with the La Nina developing, we'll see more and more cold water in the tropical regions. And what often happens is we get more cold water along the west coast of North America as well. So if that progresses as it usually happens, it'll probably lead to a slightly different outcome in 2024 fire-wise as well. Just looking at some of the Enso Springs, a lot of people will have seen this before, since we're kind of getting, pushing the number of rows we can put on one slide here. I've trimmed out some years between 1995 and 1998. I'll keep those in just because they've been fairly active fire years. A lot of area burned in 1995, kind of rivaling that 1989 total, and a lot of fire activity in Western Canada in the spring of 1998. So once again, an El Nino that was fairly strong and was dissipating during that year. Maybe a little bit later in the year than what we're seeing right now. Well, we'll have to wait for recent numbers to come out. I'm going to maybe skip through a lot of this here and just go down to the bottom. The red text here indicates El Nino years, and 2016 was a good example with Fort McMurray, Horse River fire. Blue or La Nina, so it points out some of those recent years with the La Nina and big area burned. But once we get down to the bottom, we see that we've got a fairly strong El Nino that probably peaked in December of 2023. A lot of area burned through a lot of Canada this year, and I'll maybe just point out that we had a fairly extended period of La Nina, all these blue numbers. So some people are calling it a triple dip La Nina. The index has kind of bobbled up and down, but stayed negative for a 3 or 4 year period, and probably 3 noticeable spikes, downward spikes in the values throughout that period. And a really rapid transition into an El Nino following that. So we have had, one other example of a fairly extensive drought following one of those extended or triple dip La Ninas. I think I might talk about that a bit later in the presentation here again. Just stepping back to the Pacific Tidal Oscillation, you can see the difference between the warm phase, warm water along the west coast of North America, and colder water in the central Pacific, cold phase where we've got the cold water along the coast and warm through the central Pacific, and that'll probably start to happen as we get into a more well-developed La Nina this year. Do have to point out, though, that if these transitions are rapid and if we do flip back out of a La Nina, maybe that cold water won't develop fully along the west coast of North America. So some of those rapid transitions can be a little hard to, assess impacts out of them. But there's that broad period of negative PDO showing up there. With the North Atlantic Oscillation, the diagrams on the left give the difference between the positive phase and the negative phase. So um, just really the strength of pressure areas between Iceland and the Azores Islands. So in the positive phase, we've got stronger features, tends to increase drying throughout northeastern North America. It's mainly in the winter, maybe in the spring. And the negative phase tends to increase the amount of precipitation in that area. In 2023, we did see kind of a transition from a negative phase or a positive phase to a negative phase partway through the year. So it kind of happened in there. And I think with that positive phase leading into 2023, it maybe increased the drying through northern Quebec. Transition back to a negative phase partway through the year maybe helped increase precipitation in that area again. But, we're starting out in a positive phase again just recently, but I don't think it's been prolonged enough to really have too much of an effect yet. But, we'll see how the year progresses down there. Just at the bottom, we've got Quebec area burned over a number of years. And once again, I've trimmed out some of the interim years where not too much happened. So 2002 at the bottom, there's 1 million hectares burned. You have to multiply each of these by 1,000. 2004 is very quiet. 2005 was fairly active again. Then not too much happened until 2013, where there was a large area burned. And anybody that's from the northeastern USA, if you were there in 2013, you might have remembered a lot of smoke being brought down from Quebec fires at that point. It got a lot of attention from people in Washington, D.C. as they got smoked out in that city. And then 10 years later again, well, last year, a huge amount of area burned in Quebec. And once again, the central and eastern USA got inundated with smoke from a lot of those fires. So huge amount of attention from the US once again. So, maybe once every 10 years or so, we get those big area burned events in Quebec, which may lead to a lot of smoke in the northeastern US. Of course, other problems as well. So one thing to point out in the earlier years of these records here is that the area burned in the unmanaged forest kind of north of the James Bay area northwards might not be included in those figures. So these numbers may be a bit small in some of those years. There's also a bit of work going on at the Université de Quebec en Montréal, just looking at the Baffin West Atlantic Oscillation, which is really just the western phase of the North Atlantic, and might have more direct applications to the climate impacts in eastern North America. Some of the fires from 2023 are still affecting us these days. We call these holdover fires. You see the word zombie fires a lot in the media. We tend to try to stay away from that term. Carryover has been used, but we have to distinguish in that case between the delay between a lightning strike and the actual arrival of fire on the landscape. So we'll try to use holdover fires to indicate those fires that burn fairly intensely one year and smolder away, maybe even under snow cover throughout the winter. So that happens in deep organic layers, and we've got that photo as an example in northwestern Alberta. So if you look at the trees, they're spruce trees. Judging by the somewhat club-like tops on them, they're probably black spruce, and that type of spruce grows in boggy areas quite readily. So there might be fairly deep peat layers in this region, and you can see the excavator there kind of digging up the ground and a lot of steam coming off. So we've got some heat underneath. and active fires that have carried over from 2023 into 2024. A little bit more on the next slide here. So winter remediation includes searching for heat, as you saw in that picture on the previous slide, turning over the soil and applying water to help extinguish some of those smoldering areas. We had a huge number of these fires carried over from 2023. Heading into this year, BC had about 90, Alberta somewhere between 55 and 60, and Northwest Territories a couple and maybe more. So in that little map inset, we've got the blue dots there, and I think those are the holdover fires that have been identified in the Northwest Territories. There may be more that emerge as the year progresses. Now, BC and Alberta, I think the averages for these holdover fires are probably under 10, somewhere between 5 and 10 per year. So, if we had 90 in one province and 55 or 60 in the other, well, it's, a huge increase over the average. So, quite an indication of probably fairly widespread intense drought continuing to occur in a lot of these areas and intense fires from last year. Looking at some graphs from the Canadian Wildfire Information System situation report, number of fires by province on the left, area burned on the right. The 10-year average is in red and 2024 figures are in blue. So with the number of fires, well, we can see that some of this year's numbers are showing up a little bit above that 10-year average. But if you look at the area burned, we don't have anything noticeable that's above the 10-year average, except maybe New Brunswick, and you might not be able to see it on the slide, but there's just a tiny bit of blue showing up there, and you can't see any red, so maybe New Brunswick has got a bit more area burn than usual at this time of year. So these figures are about a week old. They came from May 1st. Tomorrow we'll be compiling new data for the past week, and these graphs will be revised again, and that gets done once a week on Wednesdays, and the figures are posted on Fridays. Into the 2024 seasonal predictions. So with the ENSO forecast from International Research Institute at Columbia University on the left, where we are at the present time is where we've got this green arrow, so just follow that up. It's kind of the April, May, June period, so we're kind of in the May period right now, so we're just kind of starting out, maybe just dropping below that El Nino threshold, which is that top red horizontal line. So all these different models are predicting what the index may do over the coming months, going out to next winter. By the time we get to August or so, late summer, we're probably crossing that bottom red horizontal line with the majority of those models. So at that point, we're probably saying, well, we've got a La Nina that develops by probably mid to late summer. As you carry that throughout into the winter, it looks like we kind of maintain that La Nina going into the winter. Maybe it levels off a little bit, and maybe some recovery as we get through the winter, but still a ways off, and not too concerned about that at the present time. More interested in what happens over the summer. I guess from the look of it, it's probably a moderate, maybe bordering on strong La Nina that develops. We'll see where it goes. Just on the right here is the time series of the graph, and that's through to January, so it's a little bit behind. So at this point, we're still seeing that red line well above the horizontal black bar, indicating at that time we're still well into El Nino, but it is dropping quite rapidly. Something that you may take from this is that the El Ninos tend to spike. They're kind of a very sudden, sharp occurrence. We get into those El Ninos, and they can be very strong, but they're fairly brief usually. Most often, we're hanging around in that neutral zone in between the black bars, and when you do get La Ninas, well, they can be more extended periods. So, we see a lot of these are probably spanning 2 years, and some of the broader ones maybe 3 or 4 years. So kind of that negative enso phase is, I think, more typical as we have the trade winds blowing the usual directions from the northeast and southeast towards the equator. All right, just looking at some analog years, transitions to La Nina from an El Nino. Red areas show some of these years. So 2016, we had the big fire at Fort McMurray, a lot of spring activity. Saskatchewan was really prone to fire, but they got no ignition, so really nothing much happened there, which is fortunate because they could have had some really large fires there as well. 2017 was a little bit different as we had a fairly good area burned, and a lot of that was in British Columbia. What I think is probably different about 2017 from these other years is the La Nina tended to develop more slowly. It tended to really switch phases probably late in the autumn or early in the winter, so much later than these other years. 2019, once again, we had that transition from pretty good El Nino to a La Nina. And we had big fires. The Chuckegg Creek fire near High Level, Alberta was probably the prime example and largest fire that year. Once again, we got into summer and things quieted down quite a bit. And then 2020, which was really another outlier with barely a blip on this chart here. So a lot of fairly regular precipitation through the whole country with that transition to La Nina. It's once again a very unusual year in opposition to 2023. It came out with probably the smallest area burn that we've seen in 40 years or more. Going into model forecasting, well, we're looking at temperature forecast for June. I've kind of skipped over May here since we're partway through it. I think we'll kind of have a mixed bag of conditions through May, but heading into June, all of the red that shows up on these charts here are predictions of above normal temperatures. White areas, there's probably no signal, or maybe things are forecast to be closer to normal. And if there's any blue, well, it's forecasting below normal temperatures. So not much blue showing up on these temperature plots. And I think fairly good agreement between the North American multimodal ensemble, which is a compilation of all the North American models from Canada and the USA, and the international one at the bottom right here, which involves European and maybe models from other nations. So pretty good agreement that we're having a warm June. Noticed over the history of Gem Nemo, it tends to predict a fair amount of cool temperatures. So that's one of our Canadian models, but there's some patches of blue here predicting some regions with below normal temperatures, but yeah, still a lot of red through a good portion of Western Canada. With precipitation, it's much more difficult to forecast, and we really see a hodgepodge of predictions here. So, it's hard to sometimes take anything out of this. One thing that we are seeing is both Canadian models have a fair amount of red in various parts of the country, but some overlapping through West and Central Canada. So it indicates predictions of drier conditions than usual. Some regions where the predictions do fairly well, and get into that in a second here. If you kind of squint at the multimodal ensembles, well, the North American one has a kind of a bigger, broader patch of dry conditions from maybe the Central Prairies eastwards across Hudson and James Bay into Quebec. If you look at the international equivalent, it's got a similar picture, but a much weaker signal there. So more doubt about whether that will actually indicate dryness or not. I'm just showing the precipitation scale map for looking out to 1 month here. So the June scale map in this case, where we have some colors, yellow kind of indicates, well, we're starting to get borderline skill in predicting. If we're seeing green, well, maybe we're a bit more confident. And if we see any purple, the scales are at the bottom here, any of that purple magenta color, then we're getting fairly good skill at predicting. And you can see that really maybe the only place where some of these models have any real skill is in the tropical areas. And once you get down there, especially with trade winds blowing as they should, you can probably get a good indication that we're going to get convection in that ITCZ, the Intertropical Convergence Zone. But once we get up into the mid latitudes, well, we're showing a lot less skill. So precipitation forecasting is really something that'll probably take years to continue developing accuracy in. Stepping ahead into July, looking at the temperature maps, once again, we're seeing a lot of red on the map, so a pretty good agreement at forecasting warm conditions again. Precipitation maps, once again, it's kind of a mixture of results here. Some are showing a lot of drying, such as the GFDL spear has a lot of red through probably the western 2/3 of Canada, but we're showing a lot of green on both the Canadian models, that's in the green box in the middle, and the multi-model ensembles are kind of at odds here. So the international one is showing dryness, and North American one showing precipitation through July. It's kind of ambiguous predictions. Not showing the scale maps here, just the temperature is fairly good for a lot of the models, but precipitation is not so good. So once we see one, the rest are very similar. Looking ahead to August, once again, fairly good prediction of warm temperatures through most of the region. And precipitation, again, as usual, kind of a mixed bag of results. Once again, the international ensemble shows dryness extending a bit farther north from the States into Canada. The North American ensemble maybe limits most of that to the States, but maybe hints that the area around the Great Lakes may be dry, and we're getting agreement between those two ensembles in that region. All right, going into our NRCan seasonal prediction. So we're basing that on the two models within the green boxes that you saw on the previous slides. I'll talk about that a little bit more. For anybody that's not familiar with the Canadian Forest Fire Weather Index system, well, this is a schematic. I won't really go into too much detail here, but the red box showing the DC, or the drought code, is something that we use as kind of a baseline drought indicator within the system. So that helps build the rest of the indexes below that through the season. With the fire weather index, an offshoot of that, kind of a statistical adjustment, is the fire danger rating, and that's what actually drives the arrows on the fire danger signs there. It's usually just using linearization of the fire weather index, but British Columbia also uses the BUI, the build-up index, to help assess their fire danger. On the other side here, we can roll these values into a daily severity rating, the DSR, and on a monthly scale, we use the MSR. So we're just summing up all those daily values and coming up with a value for the month. So that's important in our forecasting here, since we're using our forecast monthly severity rating against a kind of a hindcast, a 30-year historical period, to determine the anomaly, see how much above normal those severity ratings are expected to come out. So just a little bit of text about the CANSIPS, Canadian Seasonal to Interannual Prediction System, which is the forecast system that we use from Environment and Climate Change Canada. That drives the basis for the forecasts that we produce. The two models are listed there, the CanCM4I and the GEM-NEMO, and the expansion of that acronym is given there. They're each 10-member ensembles producing 12-month forecasts, so we're actually doing 20 forecasts altogether, and kind of assembling data from those to base our seasonal forecast on. We're just using temperature and precipitation. We could use wind data, but it's a little bit harder to derive from these model outputs, since we don't have a good 10-meter or near surface wind field. We do have code in our process that we could use to run the wind, but we haven't activated that yet. Skills are probably better in Coastal areas, maybe not so good in the lee of mountain ranges. So based on our drought code assessment and fire weather index system values from those climate models, we come out with our maps. Any indication of pink is that we're seeing above average monthly severity rating for that particular month. So we've got the forecast for May on the left, June on the right, where we've got kind of a splotchy pattern. We tend to have some spots here and there. It's a lot of the values probably lie close to the thresholds between categories. So while it might show above normal areas, maybe in northwestern Manitoba, maybe it's just borderline above normal there. So um, might not have too much that happens in those regions. Likewise, in northwestern Alberta, northeastern BC, and the territories here, I mean, we're seeing some spots of above normal, and a lot of that might be driven by the ongoing fairly intense drought in those areas. Um, we have been picking up some rain, so it's maybe limiting fire activity, at least in the near term. But what's more important is that as we go through May and into June, if we get some warm, dry periods, well, we might tend to exacerbate problems in that region again. So we see a bigger area of deep red, the well above average expectations in that region, and extending a bit farther southwest to the coast as well. Start to see a little bit pick up along the Alberta-Saskatchewan border. Um, yeah, I think these regions in eastern Canada, there's a slight indication of above normal there, but those small areas, may or may not represent anything happening. Once again, it's very close to threshold borderline values, maybe, so may not be too significant. On the other hand, the forecast can miss things, and if we look at 2023 here, we've got the forecast that was done in May for May on the left and June on the right. Generally, pretty good indication of where the fire activity happened, but as we got into June, it kind of cut short that area in Quebec and did not highlight that as much above normal. So, a bit of a miss in that area. I guess on the other hand, Manitoba, we had lit up in bright red with well above average expectations, but they did get kind of a storm track that moved through there through a lot of the late spring and early summer. So really not much activity in Manitoba. So, these forecasts can go either way, just I think mainly based on limitations of the climate models. And of course, limitations on how we maybe use all of those 20 different forecasts to formulate our own. All right, stepping through again the rest of the year here. So July on the top left, we're maybe seeing a reduction in the severity anomaly again. We still have some areas that are pink, but not too much bright red. So maybe there's a period where we get some better rainfall through there. And if you remember the climate model forecast, well, it's really a mixed bag. And maybe the ones with better precipitation are winning out in this case. Once we get into August, though, that's the date is obscured, but that's the middle image there. So we're seeing a kind of a return to a lot of fairly bright red and well above average predictions through a lot of Western Canada and maybe extending east to Ontario and Quebec. And that generally may continue into September again. Areas in the southernmost regions here through the agricultural areas, may start to see grass fires late in the summer if it continues to be dry. But if you get any precipitation, it can kind of hold things in check there, maybe until you get into October and November. So, we always take those southern agricultural areas as it's a maybe kind of situation later in the summer. On the Canadian Wildland Fire Information System website, it still looks the same as it has in the past. So the seasonal forecasts are pointed to here with that orange arrow. Just below that is the oil and fire situation report. So, those bar charts, the histograms that showed earlier indicating agency or provincial territorial number of fires and area burned, you can find those in there, normally posted on Fridays each week. We are working on revisions to the website. We're hoping that it might be out for 2024, but I think that'll just be released to an internal audience and maybe to the public for next fire season. So a few conclusions and reminders. 2023 is probably an outlier statistically. I mean, we had such a huge area burn that you probably don't expect to see another year quite like that. And we do have another set of climate conditions heading into 2024. So it's bound to produce a somewhat different result. It's kind of 2023 was just that polar opposite of 2022 where nothing much happened. But with the ongoing drought, I think, we'll probably still see some areas that do have some active fire, and that's quite normal. Normal year, we get somewhere around 2.5 or 3 million hectares burned. And what we used to consider a busy year, maybe we'd get 4 or 5 million hectares burned. So, it's still possible to get some kind of outcome like that, just given the extent of the drought across the country and the intensity in especially the west. Warm summer indicated from most of the models here. Rainfall uncertain. We may get a boost with the La Nina developing in rainfall, but just a slight increase in precipitation, maybe not enough to reduce the drought or offset the warm temperatures. So we always have to keep that in mind, with the uncertainty in rainfall predictions. Maybe a quieter July, but active again in the late summer. Really, no matter what the year is like, we can have serious fires that occur. We can get some dry pockets in the countryside that may be susceptible to fire. And if you happen to get an ignition in that region, well, it can lead to serious consequences. If you have a dry pocket around a community, for example, it might result in, evacuations or property damage. And that can occur in most years, but fortunately, it's not too widespread in most average years. And fire activity really depends on the ignitions, so our forecasts only point where the potential exists. We're not trying to predict human activity or lightning activity. There are some models to do that, but they're not built into our forecast. So any areas that's lit up bright red, we do urge caution in those areas, or maybe monitoring lightning activity, since that's where we may get the intense fires going. So on the Canadian Wildland Fire Information System, our seasonal forecast is updated on the first working day of each month. Pointed that out a slide or two ago. I urge people to check daily conditions, both on provincial or territorial websites or on the Canadian Wildland Fire Information System as well. And there is my contact information. So it's the end of the presentation. I'll turn it back over to Keith and the audience for any questions or discussion.
Awesome. Thank you so much, Richard. That was another great talk. Our audience is still sort of pondering its questions. We don't have any yet in the Q&A box, so I'll offer you some that I jotted down.
All right then.
An easy and kind of stupid one is you said you don't like to use the term zombie fire.
Yes.
Is it just because it doesn't sound technical, or is there some, it doesn't sound fancy or professional enough, or is there some deeper meaning to not liking the word zombie fire?
Yeah, I guess it's there's probably different connotations to it that we tend to stay away from. We usually think of a zombie as something that has maybe changed states and remains that way, I think. And it's not really an accepted term throughout the fire community. We do have words that we use for this type of event, and having a fire smolder over the winter is not something new. It does happen after most intense fire seasons. And um, what was unusual about 2023 was just the number that did that. I think the term zombie fire was, I don't know where it originated from, but we started to see it crop up in the media a lot, but not in the professional fire community.
An anonymous attendee asks, has anyone quantified the dollar amount of commercial timber that was lost to forest fires in 2023?
Yes, I don't have numbers for that, but we do have economists working within the Canadian Forest Service. So there will be some studies going into loss of timber. I'm sure maybe, loss of structures or productivity. There's all sorts of ramifications from a big fire season, and our economic people will be studying that, maybe releasing some reports, but I'm sorry I don't have those numbers at hand.
Okay. Let's see. Uh, Somewhere early on, you compared the 2024 year to 10-year averages. I think your slide 21 seemed to show a decreasing trend in the number of fires, long-term temporal trend, and an increasing trend in area burned, which, amateurs like me want to turn into some sort of climate signal about sort of trends in the 10-year averages. Can you comment on that? Can you quantify um, the sort of the climate signal? And this matters, by the way, because you know if there's a trend toward worse or more worse fire weather, then that might mean that the past building code might not be adequate to protect us from future weather.
Yes, yeah, what you're kind of eyeballing from that chart is pretty much true. The number of fires has been decreasing. There are probably some reasons for that, and some might be kind of weird, just like the way the fires are reported. From what I understand, an unattended campfire might have been classified as a wildfire at some time, but it may not be done in the same jurisdiction, the same way in modern years. Um, People may be more careful, which is kind of a hopeful thing to say. I don't have, once again, I don't have information to back that up, but we can hope with the amount of information that is being produced these days, both kind of on fairly local or regional scales up to national and international, and a lot of media attention and other types of programs, things like Fire Smart that kind of educates people on how to maintain, vegetation around their property or building materials. I hope with all this information that people are just being more careful out in the countryside, and maybe they're not igniting as many as they did at one time. However, with the area burned, I have seen an increase in temperatures over the years, and especially in northern regions. When you get into the Northwest Territories, for example, and maybe the Yukon as well, it's I think it's almost meaningless to say we're going to have a warmer than normal year because it happens so regularly that it's just a very common occurrence. So maybe we have to start looking at a different baseline for temperatures, and of course that does get updated. I mean, climate normals get updated every 10 years, but there's some thought that maybe shorter periods are better to use for comparisons as well. And it's one thing that we're doing in fire, which I don't think we've really settled on a good historical period. We're still using a 30-year period with our seasonal forecast, hindcast as they call it, but a lot of the other statistics are looking at anything from 10 to 20 years. But then you get a year like 2020 when nothing burned, or 2023 when everything burned, and completely throws the numbers out. So what to do with the years like this, and some analyses, well, you kind of throw out your outliers and just use the ones that maybe conform to a more regular occurrence. So there's all sorts of things to wrestle with here, but yeah, I think with warming temperatures, we are seeing probably more evaporation from the landscape, which results in drier ground, drier forests, and increase in area burned. And over the past 10 or 15 years, well, we're seeing a lot more of these years where we're getting into that 3 to 5 million hectares per year burned. Once we get up to 3 million or 3.5 million, we're saying, well, that's a fairly active year.
Right. We're getting a lot of questions now.
All right.
Jorg Wittenbrink asks, could you speak about the extent to which climate change, whether global dynamics or local shifts, are driving wildfire risks? What do we know? How much can we say for today and future years?
Yeah. I think, let's start with the global dynamics. There have been some studies that come out that kind of link a warming climate with what we call a more meridional flow in the atmosphere. So it's more kind of north to south or south to north type of flow of the atmosphere. And it can lead to some, still lead to extreme cold snaps. And people often say, well, if we're having a warming climate, why is it so cold? Well, it's just maybe linked to that change in the activity of the jet stream. It's not as much east to west or west to east, I mean, as in the past. It's more north to south and south to north. So tend to get more extremes. You get colder periods and you get hotter periods. Unfortunately, though, sometimes with colder periods, it drags down very cold air from the Arctic, which is dry as well. And even in summer, I mean, you can get very dry air coming down from the north. So, each of those incidences can maybe increase fire activity. Um, yeah, it's hard to say what might happen on a local scale, but there's all sorts of factors that may come into play. I mean, the amount of timber, I guess, that's harvested, clear cut or something, may affect things. Forests are pretty good at sort of self-maintaining um, showery weather patterns and get enough evaporation from a good forest to generate a fair amount of humidity in the area, and that may help shower development. If you start taking that away, it might be affecting the amount of moisture available for rainfall.
Hmm.
I guess similarly, changes in landscape for agricultural or around urban areas may have a small effect as well. Um, yeah, once again, it's kind of a gray area for me. I don't really know the results of those types of activities.
Anita Hamilton asks, you mentioned that permanent negotiations are underway with a number of countries. Will these arrangements cover only federal crown land firefighting, or will they be available to provincial natural resources departments, EMOs, and municipalities?
Yeah, what happens with the international resources is CIFC, the Canadian Interagency Forest Fire Center, and the International Affairs Department within Canadian Forest Service negotiate these agreements with the countries. But when they're bringing resources in, they're going through CIFC, and each province or territory, has a system where they can request resources. So they're distributed through CIFC, so they eventually go out to each province or territory that's in need. As well, some of the provinces may have independent agreements with, parts of the United States. Um, Alberta, for one, also has kind of agreements with Mexico as well, or at the state of Jalisco in Mexico. So then Alberta provides training and may bring in firefighters from Mexico. So there are a number of ways that provinces or territories benefit from these agreements.
Okay, great. Let's see. Uh, Jean-Max Saint-Fleur thanks you for the presentation and asks whether the presentation will be available and will the audience have access to it. Yes, absolutely. Richard will be sharing a PDF of his slides with ICLR, and we will post the PDF and the recording of the webinar to our website. Jean, the next day or two, look at www.iclr.org / workshops, and you'll find the recording and the PDF. let's see. Kern Bab asks, what's your greatest wildfire challenge being faced regarding climate change and establishing a resilient environment? Toughie.
Yeah, that's probably a tough one for me to answer, I think, since probably requires some input or expertise from, a number of different types of people within our organization. So we're primarily a research organization. I've got my background in meteorology, and that's really my focus. But we do have some forest officers, some ecologists. And we've got people studying various aspects of, forest fire on the landscape and its causes, impacts, uh, economic impacts, things like that. So, um, I can't really answer for all of them, I think. And some of the people out in the field, some of the provincial or territorial people that are, out there, summer after summer, um, helping to suppress these fires or manage these fires, would probably have a very different viewpoint than what we do. I mean, there is definitely some overlap. You do hear some anecdotes that there's people seeing fire activity that they haven't seen on the landscape before. It's becoming more intense, more widespread. So I think there's challenges with the changing climate just to try to adapt to that new level of intensity. Or I think so. It's we also have to come to the realization that fire. I mean, it's a natural process in our part of the world and maybe many other parts, and we need some fire on the landscape to help maintain healthy forests and healthy ecosystems. So there really is this thought that we have to learn to live with fire. We have to adapt to it, and maybe that's one of the biggest challenges is just bridging that gap. We're not there yet. I mean, we've got some programs that are helping out. As I mentioned, Fire Smart before, but a lot of communities are susceptible to fire, and they might not have good ways to evacuate, so they might not have good sheltering places. So there's all of these types of things that I guess have to be developed. A lot of the more remote communities, you might have one road in which can get cut off, or you might be fly-in or boat-in communities. So there's all sorts of problems that have to be dealt with. From a meteorological perspective, the climate models that I talk about they're move about the pace of tortoises. It's every 10 years or so, you might have big advances in climate modeling. So it's going to take a number of decades before we can maybe get good precipitation forecasts months in the future. There's work that's ongoing, but it's a huge challenge, and it's going to it will take some time to come about.
And if I can stick in my oar in answering that question, no matter how good our modeling and forecasting is, to have a resilient built environment mostly means adaptation. I mean, there's climate mitigation, trying to turn around the increasing trends in temperature and whatnot, but climate adaptation means having better buildings and better firefighting and fewer ignitions. But it's hard to improve to get code improvements adopted when they are costly and when they require climbing a learning curve, when they require builders to climb a learning curve to learn how to build better.
Yeah,
Let's see.
yeah. I think just adding another point in there too.
Sure.
It's something that I really want to get out to audiences. Just across Canada, but internationally as well. As there's probably just some misunderstanding about the scale of our forests in Canada. There's huge tracts of fairly remote areas, and some of those fires become very large. So it's tough to get across the idea to people that we can't get resources out to them in a quick time all the time. Some places have road access, but sometimes aircraft access might be more difficult in some of the remote areas, and especially if there's heavy smoke, or if you get pilots logging long hours sometimes, and then they're mandated not to fly for a certain period of time. So there's all sorts of challenges with suppression, and a lot of that is just really based on the vastness of the country and the amount of remote area.
Right. William Moffat asks, looking at your charts, Quebec should have an average season. Should Quebec have an average season with warming temperatures and precipitation? I think that's the question.
Yeah,
Should
it's generally Eastern Canada. We get this you get kind of an increase in precipitation from the west to the east. So the prairies, we might get 400 millimeters per year. By the time you get to eastern Manitoba, you're probably up to 500. And by the time you get halfway through Ontario, you're probably up to 700 or 800 millimeters a year. And, it's probably more like 1,000 through Quebec and the Atlantic provinces. So we get that gradation of normal precipitation across the country. Um, so in a normal year, I mean, Quebec would usually get enough rainfall to really kind of hold fire problems in check. Yeah, they'll get some fires, and some might get fairly big, especially the area east of James Bay, which is a bit more susceptible to fire. There's not a lot of communities up in that area, so the real concerns are maybe a bit further south. And generally, it's wet enough to kind of hold things in control most of the time. Um, we do get into problems if we get a couple months of dry weather continuous, though. Um, it's possible with slight drying and increase in temperatures, you might see an increase in fire as well. But yeah, I think it takes a fairly extended dry period to really create big problems there. And with the chart, we see a big year, and then it's just kind of putters around for a bit, and then you get another big year 10 years later or something. And maybe there's periods where you can get a couple of big years that are fairly close together. I think 2002 and 2004 were, if I remember correctly, the years were examples of that. And once again, that followed an extended La Nina period in 1998 to 2001. So will we see something like that happen again? Well, it's possible. We don't have a very big sample size of those extended La Nina periods to compare to. We've got maybe a sample size of 2 or 3, I think, at the most here. So yeah, there's a lot of these things are fairly difficult to quantify at this time.
John Bignell says or asks, what are some collaborations between Natural Resources Canada and local stakeholders or communities to enhance wildfire resilience? What have we learned and how have we changed?
All right. Well, yeah, I think the Fire Smart program is one example that Natural Resources Canada has had a hand in. Right now, it's managed under CIFC, the Canadian Interagency Forest Fire Centre, but there's a lot of money that does flow through Natural Resources Canada still to programs like that. And some goes internally to our research community, some goes to CIFC, some goes to Fire Smart or maybe Indigenous programs. So there's some new initiatives coming about as well, where a lot of the NRCan money is being used to fund and develop these programs. Some might go to provincial initiatives as well. So there's a fair amount of activity in that regard. We do have some researchers, of course, that collaborate with them, local, well, provinces and territories, and maybe local communities as well to help develop better programs for the community. So it's quite a variety of activity that goes on. We are getting to the point where our staff is fairly large and diverse. So if you compare what we're doing now with what was available 10 years ago, we've got a much bigger fire program now. So we can hope that it leads to some positive change.
Cool. An anonymous attendee asks, how is artificial intelligence supporting the development of consolidated models using all the available data? And is it anticipated to use AI in the future for these forecasts? And there's a third part. Is it possible to consolidate these models against all legacy, historical, aggregated data over 30 years, etc.? So a three-part question. How are you using AI? Are you anticipating using it in the future? And is it possible to consolidate the models with past aggregated data?
Yeah, I guess the first two parts of that question, you can kind of link those together since AI development is a fairly recent thing, and there's some people exploring its use, but at the time, we don't have any direct applications of it in our modeling. But it's not to say it may not be done in the future. And we've got a lot of fairly young people on staff that are maybe more well versed in this type of activity. And as I mentioned, there is some research into it, but the one thing that we have to develop a little bit better, I think, is that kind of a link between research and application. So we have a team that has been developed to help streamline that. So and it'll probably take a few years to come about, but it's probably on the horizon.
Okay.
Yeah, and I guess kind of the historical question. Yeah, I'm not really sure if I can get the full intent of that, but a number of studies use historical reanalyses, which is observed data of all kinds that might be combined with modeled or data observed from various sources, radar for precipitation or numerical weather prediction. So a lot of these reanalyses are used in a lot of studies. It's a pretty common thing to do. And what we're doing with the climate models that we use in our seasonal forecast, though, we base our hindcast on those models. We're trying to predict what conditions were like in those past 30 years, and that way we can help reduce the amount of model bias in the predictions for the upcoming months.
Jorg Wittenbrink asked a follow-up question. Remember, he asked about climate change, and he says, as follow-up, what do we know about regional differences in how climate change is affecting wildfire risk? I mean, you spoke about how climate change is producing more north to south and south to north kind of movement of weather. How does that play out when it comes to different provinces?
Um, yeah, and I think with the bulk of the warming in northern regions, we're seeing more extended periods of heat. Well, through a lot of the country, but it's more pronounced once you get into northern parts of the provinces and the territories. So, we're seeing more heat, more drying, maybe more active fire up there, but it also affects other things like lightning activity as well. And in spite of maybe the increase in heat in the territories, we're also seeing a number of years we're having more intense thunder shower activity, and that's actually spreading farther north than it has in the past. So um, if you're getting a reasonable amount of precipitation, that it probably has no consequence. But if you're getting more lightning further north, then in those drier years, we're probably seeing a greater incidence of fire from it. Um, yeah, I think that's probably other regional differences that maybe other people could describe. I have a fairly broad view of the country, and haven't really looked at kind of regional differences, I guess, from what we've seen historically. I think one thing that I can point out, though, is that just with fire activity in recent years, we have seen a lot of large fires start to occur in regions where we don't have much of a fire history. So we do maintain what we call our National Fire Database. So it's a collection of point and polygon data from provinces and territories. And some of that is bolstered by remote sensing mapping as well. So we do have a history of fire across Canada that probably spans about 40 or 50 years. Now, we have seen fires occur in regions in northwestern British Columbia, just the region when you're getting close to the Alaska and Yukon borders, and that regions hadn't shown any real large historical fires. So 2017 and 18, we saw activity there, probably seeing more on Vancouver Island that we haven't seen in the past, so more of the maritime region. Um, Moving further east, parts of northern Ontario that are generally quite low elevation and boggy, once you get close to Hudson or James Bay. And there's lowland areas there. We've seen some large fires recently, so I think some of those areas are probably drying out more than they have historically and are more susceptible to burning. So yeah, there's a few regions of the country where we're maybe seeing these large fires pop up where they didn't occur 20 to 30 or 40 years ago.
Great, thanks. The anonymous attendee asks whether there's evidence or inference that 2020 had less fire or less area burned because of less human outdoor activity. I assume what the attendee means is COVID came and people stayed indoors, and maybe that led to fewer human caused ignitions. Is there evidence to support that hypothesis or to test that hypothesis?
Mhm. I'm sure somebody could or may have done that, but yeah, I'm sorry I don't have anything to can relate to you regarding that. So it is possible for sure.
Okay. Let's see. The anonymous attendee asks, can we anticipate a future where the prevailing west to east wind, as you noted, results in more north to south and south to north? I think you answered that already, that that is the effect of climate change, that you see more weather moving from north to south and south to north
All right,
than used to be the case. Is that right?
that's correct. Yes.
Okay.
Yeah, what we call a zonal flow is kind of a straight or relatively straight west-east flow, and it seems to be hard for that pattern to set up. In recent years, we tend to get stronger ridges. You get warmer air moving farther north, and larger, drier air pockets, and then on the other hand, you get that kind of cooler, drier moving south from the Arctic more readily. But yeah, a lot less zonal flow that straight west to east. I'm just going to go back to that question about 2020, and one additional point about that. While lack of human activity may have reduced the area burned a bit, most area burned in Canada is actually in remote areas caused by lightning strikes. So we tend to get the bigger human-caused fires in the spring or maybe the fall. But really, the bulk of the area burned is from lightning. So, and there's reasons for that. You get lightning fires in clusters, and quite often occur in remote areas. So you can get a lot of area burned before you get any suppression on it, or maybe they're not suppressed if they're far away from communities. So I think in 2020, it's probably a combination of factors, and we seem to have fairly regular rainfall through a lot of the country. I think if you look at agriculture, I mean, you can get a fairly dry year, but if you get a little bit of rain every week, maybe the crops are just fine. And I think with forests as well, if you get fairly regular rainfall, it's probably enough to reduce a lot of the fire problems. The other hand, maybe there is just more straight rainfall and less lightning, and I don't have a handle on the lightning fire or lightning strikes in 2020 compared to other years, but we can look at that data as well. So yeah, it's probably a combination of factors there.
I'm going to give you the last word in just a moment, but before I do, I'm going to I'm going to remind our attendees that we have a regular Friday forum this coming Friday, when Professor Sherry Molnar will update us on earthquakes, and particularly about the her seismic microzonation effort in southwestern Vancouver. That's this coming Friday at 1 p.m. And with that, I'm gonna thank you, Richard, and ask you if you have any last words for us.
Well, just as usual, a big thank you for attending the presentation and your questions. Always a pleasure to present. And if there's any feedback, I don't know how much of the audience is kind of repeat attendees from year to year. So if any of the material is getting well worn, I'd certainly like to know about that. And maybe some of the questions here can help lead to other material that we can put in future presentations as well. So I was glad to field the questions and see what people are thinking about. Um, as usual, I always just end with a few general statements. It's always important for people to be careful if they're out in the wilderness, and especially if conditions have been dry. So that's why always on the slides I urge people to monitor conditions at their provincial or national fire information sites. Yeah, and once again, just a big thank you to everybody.
Thank you very much. And with that, we will conclude today's webinar. Bye, everyone.
Right. Thanks, Keith. Thanks, everyone.
Bye, Richard.
Bye-bye.